So to start off this question, we're just filling out our table. Always leave yourself plenty of room in the table. Fill in our headings, and then we're going to fill in all the different material elements that they've given us, along with whatever value that we've got for those different elements. In this case, I've started working from the exterior surfaces and elements to the interior. You can do it vice versa if you want. Then we're going to fill in our conductivity, our resistivity, our thickness, and our resistance values that they've already given us in the question. At this stage of the question, we're going to start filling in some of our values. I recommend starting with just your resistance because that's essentially the value that we're looking for. Fill in whatever resistance values they've given you for whatever elements they've given you it for. Next, we're going to look at our conductivity values and fill those into our table. Then we're going to look at our resistivity values, fill those into our table. And once we're finished all that, we can start filling in our thicknesses and then using our formulas to work out our missing resistances. Don't forget with the thickness, they've given us the thickness in millimeters. In order for these formulas to work, we need to have our thickness in meters. Once we have all our values filled into our table, we can use our formulas to help us find the resistance for each material element. Our two formulas are thickness divided by the conductivity or thickness multiplied by the resistivity. Depending on which two of those things that you have, you can pick which formula suits. Once we have all that, it's a matter of adding up all our resistance values in order to get our total resistance. So the U value we've got is 0.515729 and so on. We want to round at 3 decimal places, so 0.516 is now our U value, and the unit for that is watts per meter squared Celsius. So in part B in this question, we have to find out the cost of the heat lost through that wall per year. And in order to do that, we use this formula. Now, in order to use this formula, we need to find out the value of all of those different things. We have our U value, we have our area, we have to find out what our temperature difference is. We can do that from looking at the information the question has given us. We have to work out our time in seconds. We have our cost, we know it's 94 cents per litre of oil. We know the calorific value it gives it in the question, and that's all we need to work out for now. As I said, we need to work out our time in seconds. So we're going to start off at 60 seconds by 60 minutes by 9 hours by 7 days by 36 weeks per year. Once we have all those values worked out, it's simply a matter of putting them into the formula and being really careful to put them into your calculator right. For part C, what we essentially have to do is figure out the thickness of insulation that we would have to add to this wall in order to improve the U value to get it to a U value of 0.15. We know our existing U value, it's 0.516. We know our required U value, it's 0.15. Now, what we need to do here first is to find out what resistance we are missing. Okay, so our existing resistance is 1.939. Now what we need to do is find out what the resistance of our new wall would be with a U value of 0.15. In order to find out what our required resistance is, we can use the formula R equals 1 over the U value. Now we know our new U value is 0.15, so if we divide 1 by that, we get our required resistance. Now we already have some of that resistance already in our existing wall, don't forget. The resistance that we already have is 1.939. So we need to find out what the difference is between our existing resistance and our new resistance. In order to do that, we just need to take one from the other. So the information we have now, we have our new U value, what it needs to be, 0.15, and we have the difference in resistance that we need to make up by installing this insulation. Now all we need to find out is the thickness of the insulation. In order to do that, we can use the following formula. So this is the formula that we use in part A, or one of them at least. R for resistance equals thickness divided by conductivity. We know our resistance is 4.727. We know our conductivity is 0.031 because it gives us that in the question. That is the conductivity of the insulation that we're going to add. Now, we can't use this formula as it is because we're looking for the thickness. This formula would be no good to us because we already have the resistance. So we're going to manipulate it. We're going to swap it around and we're going to bring the T back across and bring the R to the far side. So now we have thickness equals resistance multiplied by conductivity. And we just fill in our values here in order to get the thickness of the insulation that we need to add to this wall in order to get a U value of 0.15.